All right, so now that we've talked about how to graph our ellipses, now we're going to talk about how do we write equations of ellipses. So in number 3, it says find the equation of the ellipse that has a center of -3, 1, a vertex at -3, 10, and a focus at -3, 6. So let's start by putting all of this information on our graph, because we will have to graph it in the end anyways, as well as it just kind of helps us visually see what's going on. So we have a center at -3, +1. We have a focus, or excuse me, a vertex, there we go, at -3, +10. So it's a vertex. Then we have a focus at -3, +6. So if we look at this, and this is the center, and this is the vertice, that tells us that this is moving in this direction, right? So this is going to mean that y squared is with a. So we know that first of all, we could set up at the very least our problem with our center. Our center is at -3, +1. So -3 would mean +3, and then +1 would be -1. Now we know that the a value tells us our vertices. So if I look at the center and think about, well, the center moving to the vertex, that's moving a distance of 9. So that tells us our a value is 9. So I know that a squared is then 81. And because this is along the y-axis, this is elongated along the y, that means the 81 is going to go with the y. Now, we also know that the foci is found from C. So now if we look at the vertex moving to the focus, well, that's moving a distance of 5, so that makes our C value 5, right? It started at 1, it went up to 6, so that makes that distance there 5. So I know the C value is 5, which makes C squared equal to 25. Well, to find B squared, we could use our formula. B squared equals A squared minus C squared. So B squared is going to be 81 minus 25, which is 56. Now keep in mind, I don't really need to square root each side because all I'm doing is graphing this equation or writing the equation, and B squared is under here anyways. So over 56. You can square root it. I'm not saying you can't, but you're just going to have to end up undoing it anyways. So B squared is 56. It did want us to graph, so let's continue to graph. So if this moved 5, I need to move 5 more to find our foci, and then our vertex is going to move 9. So 9. Now, in order to graph, though, I do need to know our B left and right so that I know how wide to make this. So I am going to have to end up square rooting each side. So the square root of 56 breaks down into 4 and 14. So that's 2 root 14. Now let's think about square root of 56 in terms of a decimal. So square root of 56 is going to be in between the square root of 49 and the square root of 64. The square root of 49 is 7. The square root of 64 is 8. So the square root of 56 is going to be somewhere between 7 and 8. So we're just going to go out a little over 7, maybe 7.5. So then, here we go. All right, number 4 says we have a hall of 120 feet in length is designed to be a whispering gallery. The foci are located at 35 feet from the center. How high will the ceiling be at the center? So in case you didn't know, a whispering gallery is kind of interesting. A whispering gallery is a room that essentially the ceiling is kind of shaped, well, it's shaped as half, if you will, half of an ellipse, where if you stand over here and you speak out to that wall, the person over here is able to hear you even though they whispered. They have one of these designed at the Science Museum in Chicago. It's actually really cool. If you stand here and you whisper as quiet as you can, this person can hear you clear as day because of the way the sound travels along that ellipse. It's really cool. If you have a chance, you should go see it. So anyways, they told us that the hall is 120 feet in length. So I know that this length here is 120 feet away. We know the foci are located 35 feet from the center. So if this is the center, the foci are here and here, 35 feet away. And then we want to know how tall should the ceiling be. They want to create this room that's 120 feet long, but they don't know how tall to make it in order for this whispering wall to work. If they make it too tall or too short, then the whispering wall won't work. So we know this is an ellipse. If the foci are moving to the left and the right, then we know that this means that it's elongated along the x-axis, which means the a value is going to be with the x. So let's write an equation. Let's set this to be at center 0, 0. That's just going to make our life easier. So x squared over plus y squared over equals 1. Now this tells us if the foci are 35 feet away, that tells us that C is 35. Now we know the whole length is 120, which makes each of these 60. So that tells us A is then 60. And like I said, we want to figure out how tall this would be. Well, technically speaking, isn't that the B value? This is our C value, this is our A value, and this is our B value. So really, I don't even need to write the equation. Some problems we will, so I wanted to make sure we were setting it up as if we had to write the equation. But for this, all I really need to know is the B value, and if I know the A and the C, then I can find the B value. B squared is equal to A squared minus C squared. And then the square root of that would make B 48.734 feet tall. All right, last problem, find the equation of the ellipse. So the ellipse here looks like this is the center. Let's double check. 1, 2, 3, 1, 2, 3, 1, 2, 1, 2. So that's the center. So the center here is at 1, 2, 3, negative 1. So we have x minus 3 squared plus y plus 1 squared equals 1. Now, in the x direction, it moved 3, so that makes a 3, so a squared would be 9. And then in the y direction, 1, 2, b is 2, so that would make this 4. And that is the end of ellipses.